So today I'm gonna go through some of the basic properties because the idea here is to be able to use those properties in order to basically bring each and every expression into its canonical form, which is a rather simple and easier to deal with form. Therefore, we're gonna list them up so that you can understand that and use them eventually in your exercises. So the first property I want to talk about is if I have a with 0, this is just a. I know it may sound, pretty straightforward and easy, but yeah, that's indeed the property. And this is an operation with 0 and 1. Now, the second property I want to talk about is we have a plus 1. This is always equal to 1. And again, this is an operation with 0 and 1. The third property I want to talk about is a plus a, which is equal to a. And this property is called idempotent. Idempotent. And it's a very important property. The other property I want to talk about is that a naught is equal to 1. And this property is called complement. Another property I want to talk about is a dotted with 0 is equal to 0. And again, this is an operation with 0 and 1. As a property, as a category of property. Then we have a times 1, which is a. And again, it's the operation with 0 and 1. And then we have that a times a is equal to a. And this is again the idempotent property. Idempotent property. Well, actually identity more than a property, but anyway. Then we have that a times a naught is equal to 0. This is a complement property. And then we have that a naught is equal to a if we have a not. And I'm not gonna comment this one. You just, if you not something, if you not something 2 times, like having that one, double not, I can say, double not, I can say as a comment. And then you have that a b is equal to b plus a. This is the commutative property. And again, you have the commutative property in Boolean algebra. Since we are dealing with binary numbers, you have the commutative property not only for the addition but also for the multiplication. So we have a times b is equal to b times a. So this again is the commutative property. Then we have the associative property, which basically says that, well, if we say that a plus b plus c is equal to a plus b plus c, which is also equal to a plus b plus c. So this is the associative property. And again, we have it for the multiplication as well in Boolean algebra. So if you have a times b times c, it's like saying a times b times c, which is also like saying a times b times c. So again, this is the associative property. And again, we also have the distributive property. So if you have a times b plus c, this is like saying a times b plus a times c, and this is the distributive property. Distributive property. And again, it's not over because we also have distributive property in the other way around. So if you have a plus b times c, this is equal to a plus b times a plus c. So again, this is the distributive property. Distributive property. You have some other properties. One of them is the absorption, and the absorption is basically that if you have a plus a times b, this is just a absorption. And also that if you have a times a plus b, this is also just and only equal to a. And again, it's the absorption rule. Well, property more than a rule. Again, there are other properties. You have the consensus property, which is that if you basically have a times b plus a naught times c plus b times c equal to a times b plus a naught times c. This is the absorption, so those two are equal. I'm sorry, no, it's not also the consensus property. The consensus property, because those two are equal. And then you have the De Morgan rules, the two De Morgan laws, which we have been, talking about before, but I'm gonna write them in a slightly different way. Well, if you have A plus B plus C plus something, all with a naught, you can say that it is equal to A naught times B naught times C naught. And again, if you have A times B times C times something, all with a naught, you can say that this is equal to A naught plus B naught plus C naught. You can basically say that if you have all with a naught, okay, and a plus here, you can basically split it and just put a naught on each individual term and change this, okay? The same, just like you did for this, you can do the same for when we have A times something. You can basically split this and put a naught on each individual term. And of course, if you put a naught on the times, it becomes plus. If you put a naught on the plus, it becomes a times. So those are the two De Morgan laws and De Morgan laws. And then there are the last two properties, which are called the simplification properties. And those are pretty easy to deal with, because if you have A plus B naught times B, it's just like saying A times B. And again, there is another property, which is if you have A times B naught plus B, this is exactly the same as saying A plus B. And those two are the simplification property. So yeah, again, there are quite a few properties in Boolean algebra, and those are the one you're gonna have to use. And by using those, you're gonna be able to basically go from any kind of form back to its canonical form, so the easiest form in which you can represent the same expression. And we're gonna do just that in the next video.